right. Hello, SecKC. How's everybody doing tonight? Hey, so of all you lovely people out there, how many people is this your first time at SecKC? One. Okay, we got one over here. Anybody else? We got 2, 3, 4, 5, 6. Not you. 6, 7. Okay, yeah, okay, cool. So we got a few. So for most of you, you've been through this before, but for the new people, this is pretty good information. This is SecKC 101. We're just going to cover some of the, I won't say rules, but, you know, the things we like to say before we get these things started. So, you know, I just said this, welcome to SecKC. Some people said it was pretty big, but yeah, we'll see. First warning, SecKC meetings are unrated, okay? You will hear a lot of cussing, you will hear a lot of, yeah, like that. So just be prepared, you know, if that's not your thing, we get it, but that's kind of how we are around here. Along with that, we do have a code of conduct, but let's be clear about something. We don't give a fuck about your sensibilities and whether or not you are offended by what I say, okay? If you care about what I say, you can get the fuck out. What we do care about is whether or not people feel safe here. And whether we want to make sure everybody feels safe, everybody feels welcome. But we don't want to blur those lines, okay? So if you feel unsafe, find a person with a yellow badge, and we will help you out. Make sure that you've got, you know, connected with the police or whatever you need, all right? Another big tenet here. We are a bunch of hackers, but as far as SecKC goes, we want to make sure that we are not destroying data, we are not living in people's devices uninvited, okay? And we are not destroying data, right? You can do that in your own time, but not here. On that note, don't talk to the fucking cops. They're here. They will get you to say shit you probably shouldn't say. All right? So don't talk to them. Everybody belongs here. This kind of goes along with the code of conduct thing, right? Whoa, my bad. We want to make sure that everybody feels welcome. This, you know, we're all going to disagree on what I say, you know, how we go about it. That's fine, but we want to treat each other with respect. And also, everybody you meet here is probably very highly technical. In fact, there's a very good chance, if you speak to a woman here, she's more technically inclined than you are. Okay? Because I know most of them, and they're fucking badasses. So, okay, next thing. Who knows what STFU stands for? Yeah, all right. So when we have a couple of speakers up tonight, they're going to be up here with this microphone. You guys, this is a social event. This is what we're here for, right? However, when they're up here speaking, and there are people who are trying to listen to them, right up here, we want to be courteous. So there's a big wall back there with flashy lights behind it now. There's an arcade there apparently now. You can go back there. That's the shut the fuck up wall. Behind it, you're welcome to be as loud as you want, or if you need to go outside, fine, have great loud conversations. There's even a bar next door. You can be as loud as you fucking want. But in here, the sound setup in here is actually kind of shitty. We have an audio team that works their asses off to make sure that we have as little feedback as possible, but it's very difficult to hear in here when there's a lot of noise back there. So please be courteous of the speakers and the people trying to hear them. Okay, we're approaching the, I promised I would do this quicker and I'm just rambling. So I apologize. Yeah, anyway, go out and meet somebody new. That's what we're here for, right? But while you're doing that, if somebody says something you don't agree with, don't be like, man, you're a fucking idiot. Say, you know, I don't know that I really agree with how you phrase that. Maybe you want to reconsider it this way. Okay, you see the difference there? All right. Challenge the idea, not the person. If you want to volunteer, hit that website. There's ways to do that. Eventbrite. For those of you who are new, Eventbrite is a means that we can use just to order pizza so we know how much to have for the amount of people that are come. We do not keep records of people who are here. We don't collect any kind of dues or anything like that. It's all anonymous, all right? So, but if you are willing, use Eventbrite so we can kind of predict how much pizza to provide. Then we have social things, SecKC on Twitter. There is, I think, going to be a swag booth tonight. We usually have one. Justin said he would have it set up tonight. I don't see him yet, but he's usually set up right behind the shut the fuck up wall or in the corner over there. So go see him if you want some swag. Then finally we have an agenda. Take a look at it. I'm not going to read that. And that's it. So welcome to SecKC.
So we have a sponsor tonight. Thanks to Red Canary for sponsoring us, and they have some drink tickets and a Micro Center $100 gift card, I believe, to give away. So stop by their booth if you want to give away your information and get some drinks as well. Thanks.
All right, we done. Now I can drink.
Nice work. I've been up here speaking in that was the most speaking I've been.
I'm one of the illustrious founders of this beautiful organization. No to SecKC. Let's talk about SecKC. Who loves SecKC? No. You're the worst. More. Give me more. Give me 23 times more. Hey, don't fuck me, fuck you. All right, I'll take it. Who here loves 23? 23, you guys love 23? That shit is weak. All right, so I am here. Who has even heard of the 23 codes, the 23 coins, any of the 23 challenges that are out there? Who has played it? Show of hands. This is pathetic. This is exactly what I'm up here. Don't talk to me like that, fella. 23 codes is a 23 game because we love 23. The theme is 23. Who can tell me why the theme is 23? The correct answer is 23 is real. Would you like a sticker for your correct answer? Please approach the stage.
Is it a 23 sticker?
It is a 23 sticker. All right. So why are we playing a game? Who gives a shit about a game? Yes, everybody does. Why should you give a shit about a game? Because you learn new things, right? Who knows everything about just whatever you do? Just whatever. Who gives a shit? What you're doing is you're learning new skills by playing a game, and that's really the whole point, is just to learn. So, who here is going to B-Sides in May? All right, amazing. Who here played the badge giveaway challenge that was 23 themed?
Hey, how's it going? We have a long tradition here. If you say 23 on the stage, take a shot.
This is Jaeger, and the mic is getting dropped. Drop kicked back there.
Shut up and drink.
All right, so who here played the B-Sides game? Anybody? Okay, good enough. So here's what I'm gonna do. I'm just gonna walk through real quick how to solve this specific challenge to give you guys an example of what these games look like. But more importantly, if you look at the bottom of the screen, so the village is run by me right now, and the village is actually run by me and my son, and my son actually helped me put this challenge together. So as we walk through it, it's just important to keep that in mind. He's 13, by the way. So if you want to help, go to the call for volunteers 23.codes. All right. So before I go on, who can tell me the first thing they notice about if you were going to solve that image right there? What would you look for? The cow. Okay, the cow, Morse code. Yep, beep, beep, beep is not the correct answer, sir. You're terrible at this. Please go away. So yeah, let's just go with Morse code. So by the way, if you want to solve this challenge, get behind the shut the fuck up wall, and then don't listen to the solution. So, in brief, yes, you have to identify all the Morse code, and then who here? Oh my God, it looks awful. Who here has used CyberChef, or even knows what it is? All right, good. So again, that's the point. You learn new tools, new skills. Like as you go through your day-to-day job, maybe you encounter things that need to be decoded, and you don't have a full tool set. That'd be something you'd learn. But essentially, without walking through the entire thing, you need to find all the Morse code. You decode that. It takes you to a website, to a base 64, a chunk of base 64. From there, you need to decode that, and what you get is, because since my son built this challenge, he said if we're going to use CalSay, why not make the CalSay move? And that's where it's at. All right. So has anybody here played the 23 coins game at all? Yeah. Okay, good. So in brief, what the 23 coins game is there's 23 different coins at different designs that are released on the 23rd of every month. And I'll show you an example on the next page of what those coins look like. But when you solve the coin, there's a couple of levels to each coin. When you solve the coin, you get an actual minted coin with some other goodies. But these are 3-inch like challenge coins. Think about it like that. So here's an example of 2 of the coins. And so those are the first 2 that have been released. And I can talk about them, or like we can just move on if nobody cares too much. But does anybody want to know? Actually, what's the first thing you notice about the coin on the left? Coin 0. Okay, binary, why? It doesn't, yeah, no, that's how these games are played, by the way. You just toss shit out there and see what happens. You follow those rabbit holes until they stop being productive. All right, what else? Rotary dial, okay. All right, what about that picture in the middle? What do you think that is? Is that me? That's funny. Actually, some suggestions have been Chris Farley. Me. Is that Large Marge? I don't know, is it? Am I good? All right, anything else interesting? All right, so look at it. If you guys want to play these games, oh, by the way, so there's a whole, like, if you're not on Twitter following this game, there's an entire Discord, there's an entire culture that's dedicated to solving puzzles. And one of those groups is solving these challenges. And here's an example of some of the work that they're doing to solve these. So, like, I'm not going to give you that solution too much, but like that's just kind of the level of if you want to play what you might be looking at. All right. So if you want to play any of these or check any of the coins, any of the challenges, any of the anything, that's where you go. Games.23.codes. And that's it, by the way. And by the way, who can tell me why SecKC equals 23? Without reading the screen, right? Oh my God. Yeah, by the way, 23 is real, but like, that's it? SecKC, where are you guys? Come on. All right, fine. Everybody's banned. Everybody's banned. All right, love you guys, that's all I have.
Good evening. Thank you for everyone for being here, and apparently, very good. Joel's going to deliver for us tonight. So apparently we are the brave souls that are not paranoid about COVID-19, because we really can't get together with a group without hearing that at least once. Quick housekeeping thing. Again, Red Canary, we appreciate their partnering with SecKC. We appreciate their investment in the local cybersecurity. Again, we're getting the buzzwords out of the way early tonight, folks. So we appreciate their partnership and their investment in the local hacking community. So make sure you go by, shake his hand. I think there's just one guy back there, and learn a little bit about what they have to offer. They're giving out some drink tickets. So go talk to them, pick up a drink ticket. Speaking of tickets, B-Sides is coming up. I should know, but it's like April, May, something like that. We have 3 B-Sides passes to give away this evening. Now I gotta tell you how this works. This is not SecKC as an organization reaching out and going, hey, can we get some free tickets, please? Because well, that's not how it worked. Instead, two members of SecKC bought tickets and said, hey, we want to donate these. We want to give these away. So here's how we're going to do it, okay? We're going to just do a random drawing. Martin is over here at the corner of the bar. Martin, wave your hand. It's nice and dark in here. Martin is over here. He's going to head back into the arcade area, okay? We're going to follow our own rules, and we're going to stay behind the STF wall. Martin has red tickets, okay? I believe that you all are going to be totally cool with this. Yes, they match the free drink tickets that are being given out by Red Canary. No, they do not have the markings on the back of them that the Red Canary tickets have. Yes, they can be forged, but hey, we're not going to go down that road. Martin has these tickets between now and the start of our second talk. Second talk, I should have that memorized. I don't remember when it starts. It's going to start in about an hour. Before that talk, we're going to do the drawing for those 3 B-Sides passes. All right, that's how that's going to work. But let's go ahead and let's get into our first featured talk for the night. We have Brent Stone. Brent's going to be presenting this evening on reverse engineering ICS, so industrial control systems. And I'll shut up. Brent, thank you.
Hey, thank you. Appreciate it. Hey, good evening, SecKC. All right, we got one more time. Good evening, SecKC. There we go. All right, I love it. Hey, my name is Brent Stone. I'm going to be filling about 3 years worth of research into about 50 minutes, which means I'm going to be laying it on pretty thick. But don't worry, there's a backup plan. One, everything's on GitHub, that bolded link right there. If you can remember my name, keep the flyer, you can find the GitHub repo and go from there. So if anything is confusing, doesn't make sense, you want to dig deeper, or I wasn't doing a good job making it clear during this presentation, you can go into that repo, and I guarantee it's pretty well documented, and there's working proofs of concept there and data you can work off of. So don't worry about if something goes over your head now, you can dig into that. All right, so.
It's having some problems.
One second. All right, we're back. All right, there we go. All right, so industrial control systems. Why do I care? Whoops. All right, one, can't make giant robots without industrial control systems. Ever since I watched Robot Jocks in the 80s, been in love with giant robots. It's not like me. I get that a lot. I tell you what, maybe I'll plug this, maybe it'll. Hey, but the other thing that you want this, right? So, anyone heard of the Volkswagen scandal? Remember that? Hey, well, it turns out, I'm not sure if you were paying attention, but almost every single major manufacturer that makes diesel engines basically either were maliciously following the law or just straight up breaking the law, like Volkswagen. So if you care at all about what you're buying, or for example, if you're going to your doctor, you're getting an x-ray taken, I was sitting next to a guy a couple years ago, and he was very uncomfortable with this idea of automated reverse engineering of ICS.
Hey, how's it going? I heard you're a first-time speaker.
Oh, yeah.
And if you're a first-time speaker at SecKC, you get a surprise.
All right. Cheers. Salute.
Yes.
Woo!
That will totally fix your laptop too, just so you know.
There we go. Appreciate it. Oh man. Maybe if I turn off presenter mode real fast, maybe that might.
Yeah, go ahead. Better?
No, still hating it.
Here we go.
We good?
Please work. Okay.
All right, I'm gonna try to touch it as little as possible. All right, be calm. All right. All right, so also there's a great talk recently at RSA this year. Basically, any industrial control system you might work with professionally or as a hobbyist, it's either going to be not documented right, or there's going to be no documentation provided. No auto manufacturer is going to give you the spec for the car that you're driving, right? It's going to be completely opaque to you. This is going to help you do that. Figure out what the heck your car is actually doing, especially if you get self-driving. You have a car like my minivan, fit my family in there, where it's got a SIM card in there, and it's got the car take over driving from me. I can't even fight it. That raises concerns. Obviously, you want to do more than just trust your OEM that they have your best interests in mind. Again, especially if you think about medical electronics, right? Volkswagen got fined a lot of money for what they did with the emission scandal. But can you imagine what would happen if someone could actually tie them getting cancer to misconfiguration of an X-ray device or something like that? There's a huge incentive for that manufacturer to hide and bury any kind of problem that was in their system. This is designed to help us get better at documenting that without requiring a lot of manpower, especially doing it at scale, right? We can't manually hire someone to do every single device. It'd be nice if we could start making baby steps to get to that point where, just like those of you familiar with DevOps or something like that, just click a button, it's going to run through tests to verify this isn't doing what we think it should be doing. And then finally, there's a couple things in here. If you're a teacher or something like that, involved with academia, a lot of fun use cases for machine learning and a little bit of math. All right, also, why do I care to cover that? So what am I going to be talking about? Let's talk shop first. If this, this projector just really, truly hates me. I'm going to talk about diversity. And what I'm trying to get here is I'm going to be giving some specific techniques on how you can reverse engineer, but also just a way of thinking about reverse engineering industrial control systems. There's certain properties specific to industrial control systems that aren't necessarily properties of your normal network, like TCP/IP networks, that you can exploit and think about really as an ecologist. And you can think about diversity of those messages that are being sent. And then finally get into the actual applied reverse engineering piece. All right, so let's talk shop. For those of you that aren't familiar, I'm going to specifically use the use case of cars. One, because almost everyone is familiar with cars, that industrial control system. It's readily available to access. In particular, the controller area network. Okay, so right here is showing the Tesla. Teslas actually don't really use CAN. They use automotive Ethernet. But most every other car will use CAN extensively to control your brakes, to control your driving, everything that's going on in the car. All right, what does CAN actually look like? You've got electronic control units. Inside of there is a computer, and then those computers connect to all the little pieces throughout your car. All right, and then underneath your driving column, if you're not familiar with this, your steering column, there's a little connector, the OBD2 connector, and you can connect up to that to the open source protocol, well, not open source, but openly documented protocol that you can connect to and talk to the rest of your car. And then it's federally mandated that every car in the US and also by the EU mandates that every single car has this, so it's really easy to get data, so that's my use case. This is the device that we just kind of bespoke made to collect that out there, but you can get this stuff for $10 on Amazon. It's pretty easy. And it's really fighting me. Okay, the key thing here that I just want to talk to is every industrial control system is going to have some sort of ID when it sends a message. In this case, CAN has either 11 or 23, 29-bit ID. and then it's going to have a data section. I'm going to be talking specifically about looking at the proprietary payloads that are going over industrial control systems and how we can automatically reverse engineer those. All right, so hopefully that made sense, but if it didn't, let me just try to simplify it one more time. You got general use network, point A is trying to talk to point B, it's going through some arbitrary network of some undetermined number of nodes. You get flexibility, you can add and remove endpoints, and you can modify routing on the fly, but you lose determinability, okay? There's no guarantee the message will get there, there's no guarantee when it will get there. So you have this fundamental design decision, all right, do I want a general use network? One thing that is a byproduct of this, by necessity, is you have a lot of metadata to make this happen. So if you know anything about the TCP/IP stack, there's all kinds of metadata. Conversely, control networks have the exact opposite end of the problem. They're trying to say, all right, I've got multiple things, I don't want flexibility, I just want determinability. I want delivery guarantee, when I press my brake, the brake's gonna actuate, and I don't have to worry about it not getting there. But I lose flexibility. I have fixed endpoints, and I have fixed routing, and we can use that to our advantage. What we do lose is metadata, but what we do gain is they're forced to make predictable decisions afterwards, and we can use that to our advantage, which I'll get into. All right, so critical things that happen because of this design trade-off. First, payloads use a fixed format, all right? Because you don't have any metadata, the manufacturer or whoever made the ICS has to decide a priori how payloads can be formatted, so when it gets sent on the wire, all other things listening on the network know how to interpret it. All right, the other consequence of this design necessity is that you have fixed length payloads. So every time an agent on the network, some device sends a message, it's probably going to send the exact same length message every single time. That gets back to the formatting. And then finally, most of these devices are going to send synchronously. All right, so if it's an X-ray device or your car, it's going to try to send updates every millisecond or every 10 milliseconds or something like that. So you can rely on not only a fixed length, but a fixed message sending interval. And then finally, again, network IDs are typically used. So you can, without knowing anything about the proprietary logic that's being used, you can uniquely identify, okay, that's probably this sender. And senders aren't going to share IDs typically for the same reasons before. You don't have any other metadata to work with, so the other receivers need to know who's sending that data. Man, this is just Murphy striking like crazy right now. Hold on. You want me to try it? Seriously? It might work. Can we see anything? Okay, we can't see stuff. All right, well, I'm going to keep trying to blow through while we're working through this. All right. Work with me, baby. Work with me.
I'm going to swap adapters behind you here.
Okay. I got one of those. I was thinking I should bring it, but. Hey, so another thing that happens, okay, just rolling on. So because of we're working with servos, we're working with motors, or we're working with things that go whiz-whiz or vroom-vroom, they're typically going to create analog signals, right, or approximations of analog signals. And what you can understand of those type of data called time series, if you're not familiar with that, where essentially it's just samples over time and you can plot it over time. So this is what it looks like. You have observed payloads at the top. I've got 8-byte payloads, I think, here. And then I extract that out. So I look at, all right, interpret that binary data or hexadecimal data as integers. And then now I can label that, all right, this is my vehicle speed. That's looking pretty good. Yeah.
Do you need speaker notes, or are you good with that?
No, I'm fine. Okay, we'll be all right. All right, so, but now you get these two different types of modalities, right? So while there is a lot of vroom vroom or whiz whiz, there's also a lot of states that the ICS might be trying to keep track of as well. So how do I differentiate between these two types of data? That's one thing that we need to kind of figure out ahead of time to automate this process. So let's talk about ecology. So if I go into a biome, the biome only has wolves. That's not a very diverse ecosystem, okay? It's just one, actually, if you put a numerical value to it, it's 0. There is no diversity. It's just one type of animal in the ecosystem. But if I've added a little bit of rabbits to it, so some prey, now I've got a little bit more diversity, but not quite diverse, right? The wolves are going to eat all those rabbits, and then it's just really wolves again. And then if I add a lot of rabbits and then a little bit of deer and snakes, now I'm getting more and more diverse. And then finally in ecosystem D, I've got arguably, from a quantifiable standpoint, a perfect diversity. Not only do I have all 4 types of animals represented, but I've got equal proportion, if you just counted how many there were, each animal is equally represented, okay? So my diversity is going up as I move from left to right here. So the way that you can quantify this is the Shannon index, okay? The Shannon index, you've heard of Plot Shannon, information theory, same thing with entropy. Now I have a numerical way that I understand how diverse a signal is. And this gets to how do I differentiate whiz-whiz signals from state signals, okay? Just a side note for those of you, I can almost guarantee I'm probably the smart person in the room when it comes to actual hacking in here. But just a side note for those of you that aren't familiar, actually. This is the essence of cryptography and compression, okay? If I can identify repetitiveness or disproportionate proportions of the different, of the different specimens in my sample population, whether that's numbers, letters, and your plain text that you're trying to encrypt, or this is your time series data that came off an industrial control system. If one type of value is overrepresented, then you're going to have a less diverse population. And the goal of cryptography is to create perfect diversity by maximizing entropy. Same thing with compression, it looks for repetitiveness, and then it just simplifies that into a single value and saying, all right, just repeat this 7 times. All right, so now that we've got a way to differentiate state from more analog signals, so that's one step in the process of automating this. Next part is how do we actually break apart these payloads? So let's say we've got a sentence, and we want to break that up into its individual words. Each word would be a token. This process is called tokenization. If you've ever worked with compilers or something, this is what their bread and butter is. Now I look at payloads. One way that you can look at the data is take the whole sentence in one big chunk. Not a good idea, but you could do it. So I take my payload, take it one big chunk, I get some output, but it's probably nonsense. Now if I actually put a little bit of nuance in this and I take apart each individual word, now I get each individual time series. And this goes back to the design trade-off of having an industrial control system. Oftentimes, for speed, I need to embed multiple pieces of information in a single payload, and that one transmitter is sending that same information over and over again, so I can exploit that to try to find what individual pieces of information are embedded in the payload. So how do I do this? There's actually an extremely efficient method for doing it using just XORs. So let's say I'm looking at data coming over the wire, and here I've got a 10-bit payloads. I'm looking at transmissions from top to bottom occurring over time. So the top payload is the first observation I see, the first transmission from that industrial control system agent. And then the second payload is line number 2, et cetera, et cetera. So if I'm looking at all the payloads coming across the wire, what I do is I create a copy of that data, and you could also just do this with a few registers if you wanted to. I shift it by one row, and then I XOR the 2 observations against each other. What this tells me is when a bit flips from 1 to 0 or 0 to 1, I can record that through the XOR as a change. Okay, I'm looking for diversity. And now I've got this record of how many times a bit is flipping. Well, because we're using Turing machines, because we're using binary encoding, which almost every modern computer has to use, you're going to have a least significant and a most significant bit. And by necessity, if you have numerical data, that least significant bit is almost always going to transition more frequently than your most significant bit. Not only that, but it's going to be a generally smooth gradient of transition frequency from your most to your least significant bit. So you can do this by just summing up the resulting XOR matrix. And if you look at it visually, then you get a pretty good educated guess on where the unique pieces of information embedded in my payload are, okay? And we're doing this all by looking at diversity of single bits or messages as a whole. And now this is a real world example from my Prius. At the front we got some sort of checksum, and then we've got 4 instances of my RPMs, and then we got some more metadata at the end. Okay, so we've got 2 elements to break apart individual payloads and then compare payloads to, whether it's an analog or maybe a digital signal. So how do we add on to that? How do we tell one signal looks like the other, apples and oranges? All right, so this is one example of the results of breaking apart a payload and the output. And as you can see in the middle, I've got 4 instances of data that look almost exactly like each other. So if I'm trying to automate this, I want to find all these instances that look like each other, not just in this payload, but across other payloads in the ICS, and then I want to correlate those all together. Okay, so here's agent 0, 1, and 2. These are different parts of my car talking on the network. And as you can see, highlighted in orange, almost the exact same data is being transmitted. And this makes sense, right? I've got 4 wheels. Each wheel is telling me how fast it's rotating, and so I'm going to get repetitive data. But then you get in this more nuance. If you look at the blue, okay, this right here is kind of chunky, but it looks kind of similar to this, but a lot less similar than this orange looks to that orange. But they do look similar. So how do I actually capture how similar everything looks and make a decision about that? All right, well, ecologists already figured out how to do this. We have a million different types of bugs, and we've got a systematic way of categorizing this bug looks this similar to that bug. It's a tree of life, okay? And then we've got a machine learning technique that does the same thing, agglomerative hierarchical clustering. All right, if you're not familiar with machine learning or anything like that, essentially it just says, you give it a distance metric, okay, so how similar these two things look, and then I will tell you how to group them and create this, it's called a dendrogram, but you can think of it the same way as a tree of life. How similar are these two animals? All right, the nice thing about agglomerative clustering, we don't need to know how many different types or categories ahead of time, which is critical. Most of these machine learning techniques, you gotta give it a guess ahead of time. How many categories am I expecting? Hierarchical clustering doesn't force you to guess. And it could also work with a single distance metric like pairwise. And then, like I said, that dendrogram gives you a very intuitive idea of how similar things look and how the network is looking. In this case, I'm just using, as long as one animal in this group looks like another animal in this group, or a signal looks like this signal, I'm going to say the whole group over here looks like this group over here. Okay, that's single linkage like that. But there's other ways to go about that. Like, I want to look at the most dissimilar representative of this group and the most dissimilar representative and use that as a metric. Okay, there's different ways to do that. I haven't explored these other ways of doing it. If you want to get published or do some research, it's certainly something worthwhile to do. Okay, and then how do I actually how do I tell how similar these signals look like? I interpolate and then I create a correlation matrix. Correlation matrix basically just says how similar does this squiggly line look to the other squiggly line. You get out this big matrix here, you plug that into the clustering algorithm, and then it goes from there. Again, if you're not familiar with machine learning or anything's going over your head, please look on the GitHub and it'll explain everything. If I get a distance matrix, so I want high correlation to represent low distance. Okay, when I'm clustering, you just take 1 minus that correlation matrix. So if I have 99% correlated behavior, then I want a very low distance. So you just do a conversion, and then you plug that into the clustering algorithm, and it all works. All right, so now I've got a way to extract information from my payloads. I've got a way to say what information in each payload looks similar to each other automatically and in a general sense. And now let's take it one step further. Okay, and this is where it gets a little bit heavier. So let's say cars in particular, they've got a protocol J1979, same way that the Environmental Protection Agency and NHTSA, National Highway Transportation Safety Association, found out Volkswagen was cheating was because the whole reason that port is underneath your driver's column is you hook up to it, and then you hook something up to your exhaust pipe, and then you can say, all right, the car is doing this, and my emissions should stay below this threshold. So J1979 is the federally mandated protocol that the car should comply with. So I can ask the car certain questions, like what is your current RPM, what is your current speed? Now that's only covering about 10% of the total car. Everything else is proprietary, hidden, and obscured, which is why Volkswagen, Nissan, and all these other people were able to get away with this for so long. So I've got a little bit of labeled data, and I've got a way to cluster them together. So I've got my speed and RPM, but now I've got all these other signals that are proprietary. I would like to know what they are. Well, I can objectively say and automatically say, well, there's some causal relationships, right? When I see this line go down, or if I see this line go up, this other thing that I don't know what it is goes down or up, all right? There's a cause and effect there, and I can observe it visually. Well, I can also observe it automatically too, algorithmically. And so this goes back to predator and prey, right? As my foxes go up or my predator goes up, my prey population is going to go down until it gets to a certain point where they run out of prey, they start starving, they die off, the prey, repopulates, and then this cycle starts all over again. You got this cause and effect. Well, I got the same thing here. It turns out that there's some really exciting science going on at UC San Diego and elsewhere called empirical data modeling. We've all heard this trope, whether in math or something, that correlation does not imply causation. Well, causation implies causation, and there's actually a way to test for causation now. And let me give you one example of how we do it. So what they did, here's one experiment from, he's an ecologist, the guy who kind of built on this, George Sugihara. He was looking at a cell, and he gave a special ink to the cell to fluoresce as it was doing something. I don't know, I'm not an ecologist. And so what he did is he took a time series of how brightly that cell fluoresced over time. So here at the top, we've got this time series that we're observing. And then, again, I'm not going to go into too much detail right now, but you can create this sort of three-dimensional representation, or actually n-dimensional representation of this time series. So you kind of get like a 3D model of what's happening. And as you can see, it's kind of spinning around here, and then when it's about to go dark again, it's going to hang out in this lobe down here. So right now, see, it's almost totally dark, and then it's about to go back, and you'll see it kind of transverse this little road right here and go back up. And what that gives you is a lot of predictability. Now you have, without knowing what's going on in that cell, now you can have an extremely accurate model of what is happening. So again, we don't know what the manufacturer made this thing to do, or we can't predict a priori what we're trying to get out of this system, but we can create an accurate model. And so what this looks like in practice is your car is what's called a dynamical system. Okay, so you're part of the car. So when I was looking at this data, what happens is I'm over here and I'm anticipating I'm coming up to a stoplight, so I press the brake. So my brake pressure goes up, and then it goes down when I come to a complete stop. And now I've got other data that's coming out of the same system. Your car is one system. Let's call this my RPM, and let's call this my vehicle speed. Okay, so all this stuff is related to each other. There's a cause and effect going on throughout the car. And when you plot all these, again, you can make this three-dimensional or n-dimensional representation. Again, I'm not going to go into too much detail why that is, but what I can do is, just looking at the time series I get out of the car from the stuff I already talked about, I can recreate this and now make predictions on stuff that I don't know what it is. So if this is my RPM and speed that I can get from J1979, and I don't know what this group was, I can still measure how strong that causal effect is. And what this allows me to do is, if I've got this, then I've got this representation. This is my model for brakes, this is my model for RPM. Turns out there's a one-for-one relationship between these two. The mathematical term for that is diffeomorphic relationship. Again, I'm not trying to impress anyone with these words, but I'm just throwing it out there so you've got it available. What happens is, as this is going around our cool little sketch here, every single point on here is going to relate to exactly one and only one point over here. So what that allows me to do is just like machine learning, where you can make models that predict, okay, my next value is going to be 10, my next value is going to be 11 based on my previous values. You can do that for this stuff that you have no idea what the data is, and it's in this dynamic relationship. You can use these models to make predictions of each other. The net effect of this is, now I can look, all right, this is my RPM, and this is my unknown, let's call it brake. If I take kind of 3 points on that model, and I move it one timestamp, look at how accurate that prediction is for where the new value is on that model. Now I can quantify how good my manifold is for predicting. The end state here is, now I've got my speed, I've got my RPM, I don't know what this is, but I can tell you how strong those causal links are, okay? And this goes back to the automating piece. Well, now if I have several instances of training a supervised learning algorithm, saying like, hey, speed and RPM, if you see this kind of causal strength and you see this causal strength to another cluster over here, because we've trained this system, I know that's a break, okay? So now you can get into this thing where it's completely unsupervised at some point. You can reverse engineer your entire car as long as enough people add data to the training model to say like, hey, I've observed my RPM and speed have this strength of a causal relationship onto my braking signals, and now we can completely automate the whole thing. All right, so let's go to the actual application here. This is the code that you would see on GitHub, the whole point. The only thing that you're going to need to modify is this first part up here to change it to any other protocol. I've already changed this code to several other protocols. And by and large, the only thing you need to change up here, there might be a little bit of data massaging that you might need to tweak here and there, but by and large, if you want to use a different protocol other than CAN, just change the protocol-specific pre-processing that's on the GitHub. Lexical analysis is what I talked about earlier. You take tokens, like this is a sentence, you break it down into individual words. Process is known as lexical analysis. Your compiler does it all the time. And this is how we specifically get after, algorithmically, the process I talked about earlier, where I've got multiple pieces of information embedded in my payload. I want to get these time series out of that. I see these hills right here. You can just do a hill climbing algorithm. So you start at the first bit, so bit 0, okay? I'm going to move to the next bit. Is that bit greater than or less than the one I just saw? If it's greater than, then I'm going uphill. If it's less than, then I'm going downhill. Okay, and this automatically accounts for little endian or big endian encoding, another necessity of Turing machines and binary encoding. Now I just want to keep adding the bits together and assume that they're all part of one message as long as I continue to go uphill or I continue to go downhill. If I all of a sudden have a big change in that, then I can assume that I've come to one of these edges right here, okay? And now I need to start there's a new piece of information embedded in this payload. Once I've reached an inversion, okay, so I was going uphill and all of a sudden I'm back at 0, or I was going downhill and now all of a sudden went back up, start a new thing, and then beginning with wherever that new bit was, start there and begin the process all over again. Two little tweaks to this simple hill climbing that you can do is one, decide if you want to use padding bits. So a lot of times manufacturers, for one reason or another, decide not to use a bit at all. So there will never be a flip. It'll just always be 0 or always be 1 every single payload that's transmitted. So you can decide, all right, do I want to include those padding bits when I cluster and interpret this data? The second thing you can do in real life, there's not always a perfect hill going. So you can see here, like I've got a little bit of a bump down. I went downhill a little bit. So when you look at this code on the GitHub, there's a variable there called max inversion. What that's allowing you to do is account for it going downhill just a little bit and accept that and continue to cluster those bits together to group them into one piece of information. And that allows you to give you a little bit of flexibility and tune it. I have not explored using different values or smarter ways of doing it. I just picked 0.2 for every single car I looked at. Worked good enough for me, but that's certainly something that can be improved on. And then finally, semantic analysis is this process of, I've got a sentence, I broke it up into different words, but now I want to know the word sentence, what type of word is it? It's a noun. Okay, so now I've applied meaning to what it is. That goes back to the apples and oranges piece. You know, if I know one thing in this cluster is RPM, because I asked for that information, I can say everything in that cluster is RPM. That process is known as semi-supervised learning. But the way you do semantic analysis, slice and dice those payloads, interpret the data as a time series. Now, this is another piece where I just ran out of time and got a little bit lazy, and I could definitely use smarter people to help me with this, is I just assumed everything was unsigned integers, but that's obviously not going to be the case. There's a lot of signed numerical data in there. There's non-numerical data. So if you look at the code, just know that step, I just sort of fudged it and just assumed, okay, you're going to be a number, and you're going to be an unsigned number. I'm going to normalize and interpolate. So like I said, everything that's working on the network, it's going to probably send things synchronously. Some things are asynchronous, but things are going to send at different synchronous rates. So one thing might be sending thousands of messages a minute. Another thing might be sending one message a minute. So I need to be able to compare those two equally. So I have to interpolate my data to whatever my most frequent transmit rate was, and then go from there. Calculate that correlation matrix, which I talked to you. If you're not familiar with correlation matrices, don't worry about it. It's just a measure of how similar two things are. Filter based on that Shannon index. Okay, so if I want to say, hey, I don't care about state, I don't care about digital signals, I just want the analog, because that's what I really care about. I personally chose to filter those out, but you can make a different decision. And then I removed any negative correlations. So by negative, I mean if this goes up, the other thing goes down, that's a negative correlation. I just ignored those for the time being in the current code, but there's something that you can definitely work on. Cluster them, and then partially done, look at the causality between clusters that I talked about. One thing that I did not get time to do was build that supervised learning algorithm. Again, all this code is on GitHub, and it's 90% of the way there to do this supervised stuff, but it's going to take that little bit of extra effort. All right, so how well does it all work? What I found is almost every single car, I had over 90% consistency or accuracy. Now, anyone that knows working with interpreting data, if you're off by 1 bit, that's going to screw up your whole interpretation. And if you're only assuming everything is a signed integer, that's also going to screw up your interpretation. So being 90% is not good enough. You need to be 100% accurate. Even 99% accurate is going to be kind of rough. So if I miss that most significant bit, that's going to be a big problem for me. If I miss that least significant bit, I could probably survive that. But what I found is over time, no matter what driving conditions I was working in, or if I split and recombine my data in a bunch of different ways, I maintained a lot of accuracy. Now the question of how do you know accuracy without knowing the truth data, that's a whole other topic that is on the GitHub and in the documentation, but I don't have time to talk about here. But basically what I found is whether I was driving on a runway, so I just was on a straight drag, tried pedal to the metal, got to the end, turned around, pedal to the metal, went all the way to the other side, or if I was driving in the city, or if I was in my full commute from my work to home, the results were identical except for the city driving. I changed one thing. It didn't grab this. I think I filtered this out. And again, I'm just using non-tuned parameters. I'm not particularly trying to be good at this. I just used default settings that I thought looked okay, good enough. So it's pretty accurate so far, but can certainly be improved. With that, I got a folder with the 17 cars that I've personally looked at. I'm happy to walk through the results and output and answer any questions. So I'll open it up from there. Yeah. Yeah.
And my follow-up question to that is that you showed a 3-axis kind of correlation there, where speed, RPM, and brake correlated. If you were to apply the same model to like cars, and you were to use gears, and you were to add a 4th axis into there, would you get the same kind of results if you were to say I'm in 1st gear, I've got this RPM, this speed, I apply brakes, I'm in 2nd gear, I apply axis, and I apply brakes. I mean, how many axes can you get into this correlation?
Yeah.
That's all I got right on that one right there. Thank you very much.
Yeah. So the two questions, if I understood them correctly, the first question was, from an academic standpoint, what's kind of the Venn diagram between computer security, machine learning, and just traditional computer science? Is that fair? One, I just want to really, truly reemphasize that I am a terrible hacker. If you define hacker in like a very general terms, or even a cybersecurity person, in a very general term of making things, using things in unexpected ways to get cool results, then sure, I consider myself a hacker. But if it's something like the next speaker, you know, working through the Stan's Holiday Hack Challenge, I would bomb that stuff all the time. But I would consider myself a decent computer scientist and a decent machine learning guy. What's the overlap? I think that really depends on your goals. If you're really trying to make, if your only goal is like maximize your paycheck, then certainly machine learning and cybersecurity are great. And if you can combine both of those, then even better. If you've got the time, really my biggest recommendation to anyone trying to get into this field or develop their skills is take a statistics course before you do anything else, even computer programming. If you understand statistics and you understand linear regression in particular, just that very, I call it foundational, but really it's almost kind of master's level. You'll understand machine learning 100% better than people who just click the button. Understand statistics, go from there. The second question was about the embedding. So the other nice thing about empirical data modeling and what George Sugihara is doing is this can also automatically be done. So determining the correct embedding, so let me back up real fast. I'm using the word embedding. What embedding means is how many dimensions are you using? So 2-dimensional is a plane, 3-dimensional is kind of what I showed you. The time series is arguably 1-dimensional, okay? All the EDM stuff, and there's a link to it on the GitHub, and I barely understand it enough to talk about it. It can automatically tell you the correct embedding. So if you remember Jurassic Park, okay, and he has that, you know, that chaos theory thing of like, you know, a butterfly flaps its wings and then it affects, you know, someone crashed in China, okay? This is the same field of study. What this empirical data modeling can do is, yeah, well, the butterfly flapped its wings, but it really didn't have a substantial effect. There's actually, it'll automatically tell you how many things you should consider when making that model to capture what's necessary. So it'll tell you the correct embedding. So for me, like if I'm trying to make a model for my break, I just give it all the data that I have, and it will tell me which data I should be using to recreate that manifold. So I'm sorry for anyone else if I'm talking over your head. But yeah, so it can tell you what data really counts.
Thank you so much.
Yeah.
Can change between metric and English units displayed.
Yep.
Does it change the data, or does it just change that on the display?
So one thing I did to sidestep that problem is I normalized everything. So I assumed everything was numerical data, and again was a cop-out move on my part, but I assumed everything was numerical, and then I normalized it, and by that I mean scale it from a 0 to 1. So whether it's using US or metric units, it's going to create the exact same time series, if that makes sense. But that's a cop-out because at a certain point you might want to know, all right, well, what is my actual value? And that's where you're going to have to do some manual reverse engineering, say like, all right, it got me all the way, I know exactly what bits and what transmitter I'm paying attention to, but I want to know like the actual speed or the actual RPM that the car considers. You're going to need to like add a scaling factor back to that time series to find that out. So one that I'm thinking about it, one thing that would be an interesting research avenue is because we've got this J1979 data, I can get the actual vehicle speed, and then if I know like, okay, I think this signal of this time series is vehicle speed, then I can probably just do a division or a multiplication and figure out that scaling factor automatically. So if for example, you have some truth data available, then you might be able to figure that out automatically. All right, thank you.
That was straight up legit. As a reminder, the raffle tickets for the 3 B-sides passes. First 2 are normal, just your normal entrance badge. Last one is one of the B-sides blinky badges. Those things are super, super cool. I didn't get one this year. I didn't get signed up in time. But those are pretty cool. So anyways, I can't see anything right now, but Martin should be in the back. He's wearing a beige sweater. He has tickets still left, one ticket per person. See him, and we'll do a drawing here. We're gonna move Giota up a few minutes to try to get you guys out of here a little bit sooner. So 10, 15 minutes worth of tunes. and we'll kick off the second talk where Eric's going to talk through the doing very well in the Sam's Holiday Hack Challenge. So back with you in 10 or 15 minutes. Boy, what a. Boy, what a. Am I off? All right, no. There are we. Yeah, but it's not anymore. Try it now. Hello. Do I need to reboot it? I'm not muted. Hello.
Very patient crowd there. I like that.
What? It's on and it's green. Yeah, need to reboot the mic? Okay.
Classic reboot. Solves all problems.
All problems.
All right, we're sending audio lead back. Check 1, 2. I don't have a loud voice left. It's looking good. All right. I can actually smile now, yeah?
Right.
Jurist, yeah? Loaded picture?
Yeah.
It's good. All right. All right, is Martin? Martin, are you coming up, buddy?
Oh, cue us off. I break
Spelling.
everything that's here, so it's my fault.
So where are you from?
Denver.
Denver? Cool. Thanks for coming.
Yeah, man. Happy to be
Travel
here.
for a living, or is this just kind of a side like, hey, get your butt out there?
Sales guy, so
All right, okay.
yeah.
Slide.
Slide.
Check 1, 2. We had this working earlier. Your stuff coming? You good? You need anything from us?
Nah, I think I'm good.
Okay. Alrighty.
Yeah.
Looks good to me. And I'm looking forward to this. I played around with last year. I didn't do this
Did you?
year's.
Yeah.
I got nowhere.
Oh,
So
man, yeah, it's
I didn't
fun.
put any time into it though. So
That's the thing, man. It takes so much time.
Yeah.
Like to go through it. It's a time crunch.
this is
but-
cool. I'm looking forward to it.
Yeah. Sweet, dude.
Check 1, 2. Do I need to change
Hey.
mics?
This is the one you want to go for?
Yeah. Boy, we found a volume switch there. You know, we harass is not a politically correct term anymore. We good-naturedly rib the audio team, but I will tell you that those guys were here at 3 o'clock this afternoon, and they will likely be the last ones out of the building tonight. Those guys work harder. They work harder and deliver month after month after month for us. So they work seriously hard. So we're grateful for that. All right, Rob with Red Canary. Again, we're grateful for Red Canary stepping up, sponsoring, partnering with the local hackers community here. And we have a drawing for a $100 Micro Center. I almost said Microsoft, but we'll do a Micro Center gift card. Go ahead.
I also have lots of drink tickets left if you're still thirsty. Just saying.
It's really excitement there. All right.
All right, this is going to be for the Red Canary drawing, and we have number 135053. You have to match all 6 numbers, not just 2. 135053. Can I see a hand? Do we have a winner here? We got a winner. We have somebody walking over here. Okay, super. Thank you. Thank you. So we're going to take this, and we are going going to make a mess. Alex, are you up here? Alex, you're supposed to be up here. All right, Martin, thank you for helping with this, for facilitating. Jonah's up here. Alex is coming. All right. All right, here's what we got. We have 3 passes to B-sides. First 2, and again, remember, these are bought by SecKC members, and they are donated. So pretty cool community effort here. Last one will be for the Blinky badge, the B-sides badge CTF. Brian, Archos, here. All right, first one, first winner. I'm gonna have the winner. If you come down, Alex, raise your hand. Come see Alex because we're gonna need to get some contact information from you to, yeah, well, we won't joke about what it's going. It's just to facilitate that name transfer. Number 135, 123, 135, 123. Can I see a hand? Do we have a winner? I can't see anything. All right, we're gonna keep moving really quick here, so I'm gonna redraw this if I don't see a hand. Got a hand. Thank you. Thank you. We got a winner. Okay, first winner, first badge. Come see Alex. Yep, step right up here. Alex is here. Archwist, can you draw another one for me? Second B-sides pass. Second B-sides pass. We are looking at 1-3. All right, guys, it's 135. Okay, do we get that? It's people 135. I'm still working on this. 099. 099. All right. Very good. We got a winner here. See, Alex, last one. This is going to be for the Blinky badge. Blinky badge. I'm sure you can guess the first 3 numbers at this point. It's going to end in 095. 095. We got a winner right here. Superb. See, Alex, right here. Let's get your name down so we can make sure these badges get registered in your name. Thank you. Thank you guys. Thank you all for your participation there. All right. Last talk. I was really excited about both of these talks tonight. You're not going to go to another meeting in Kansas City and get tech talks like this. Like, this is just amazing material here. Giota is up next. Some of us have played around, some more than others, with the Sands Holiday Hackathon, Sands Holiday Hack Challenge. As somebody that has done that and not made real good progress, I have high levels of respect for those that have navigated through that. And Eric's going to come talk to us about his experience with it. Eric? There you go. Thank you.
Thank you.
Woo. The last talk of the night. Oh man. Thanks for everyone for sticking around. I know it's a little bit later than usual. All right. Hopefully this is beneficial to you guys. I'll try my best to explain what I did, a little bit about what happened, but I will be talking about the SANS 2019 Holiday Hack Challenge and how I was able to hack my way to super honorable mention. So, yeah, that's me, Eric. I go by Giota. Okay, raise your hands. Who has actually done the SANS Holiday Hack Challenge? Has anyone actually done it? Knows what it is? At least a little bit? Cool. All right. Perfect. I'll explain a little bit what's going on. That way we can kind of have a little foundation on everything. So this is an annual hacking challenge made by the SANS organization. They do cybersecurity training. They do certifications and things like that. So SANS and the Counter Hack Challenge group, they come together every year. They make this holiday hack challenge. It's released around December of every year, mid-December, let's just say December 15th. And you can think of it as a CTF, maybe like a themed-based challenge where you actually have to use, cybersecurity skill sets in order to solve these challenges. So as you progress, you can actually formulate yourself a write-up, submit it into this Holiday Hack Challenge group, and you can get entered into a contest. So this contest, they give out swag, so like t-shirts and stuff, but they also give out some pretty cool prizes, such as a subscription to Networks. So if you've never done Networks before, I have not either. Supposedly it's pretty cool. You can actually win that. They actually have training. So on-demand training, live training, they give this all out for free just by submitting into it. So about a month after the window closes, so it closes around mid-January, around February, they announce the winners. They will go over a couple different categories, one of which is the honorable mention. They'll give that out for people that they just want to recognize for doing a good job. They'll also give out a super honorable mention, which, their words not mine, is a category they give out for people who went above and beyond their entries. Their write-ups are considered superb, demonstrate excellent technical stuff, and speaking as well. So pretty cool to have, I think. So that's it. After that, here's Trent.
Hey, how's it going? So if you're going to talk about Christmas in 2020, and you're at SecKC, you have to have a shot.
Oh boy. Jaeger.
We got two, Eric. It's gonna be a long night. And if you get a super honorable mention at KringleCon, like Eric fucking did, you get a shot.
That's the SCOTUS bomb. It's SCOTUS.
Yeah. Thanks, Eric.
Thanks, guys.
Take it.
Oh, man. Thank you, guys.
Thank the Lord.
Means a lot. Okay. I forget where I was, but let's just say that they hand out 3 grand prize winners. I was not one of them. The winners that did win did an awesome job. You need to check them out. If you go to their website, the Holiday Hack Challenge website, you can actually see the winners that won, what they did in their write-ups. Awesome stuff. Okay, so I said this is an annual hacking challenge, right? So this actually is hosted every single year. But what happens if you miss either this year's, previous year's, things like that? Well, you can actually go back and actually work on these if you missed them due to whatever reason. If you weren't available, didn't have the time, weren't there yet, weren't born yet. I mean, yeah. They're still online today for you to practice on. So check them out if this has any interest to you. They're all theme-based. So in 2017, it was called Wintered, kind of like the spin-off of Wicked, the musical or whatever it was. 2015, they had a Gnome in Your Home challenge, spin-off of Elf on the Shelf. It was like this command and control device that you had in your home that was beaconing out. Pretty cool. Theme-based, which makes it a little bit more fun when you're walking through everything. So last year, the 2019 one was called KringleCon 2. The previous year was called KringleCon. Basically, Santa Claus and some elves are hosting this conference up in the North Pole. So this year, our job was to figure out who stole these 2 turtle doves and why did they do that. So I want to go over a little bit on what you can expect when you do the Santa's Holiday Hack Challenge, because I had done them in the past. I hadn't really spent that much time on it, and honestly, I was kind of weirded out. It just felt weird for many reasons. One of which, you just have like this avatar that you're hopping around with, and it was really confusing. I kind of want to clear that out. That way you're not kind of intimidated or turned off by something like that at the very beginning. So when you log in for the very first time, you have this avatar. You're navigating around with the arrow keys and the mouse and all that. You will bump into these NPCs, these characters that have green writing over their name. You can actually interact with them. Click on them, they'll talk to you and tell you about what's going on, what you need to look for, kind of just go over the whole theme of this whole challenge. So, also you'll notice that these NPCs might be standing next to this Raspberry Pi terminal. What this terminal is considered like a mini challenge, something that you can do in a relatively short amount of time. The challenges vary in types. So for example, one of them this year was like an IP tables challenge. So if you've never done IP tables before, one of these challenges do that. You actually block stuff. Pretty cool. PowerShell's in there as well if you need to do some navigation, look for a particular file, maybe like a Christmas present somewhere, whatever, but it's all in there. You can do it really quickly. If you're at the library at some computer that isn't yours, you can log in and actually conduct these. It's a little mini Linux terminal, pretty fun. So if you do these mini challenges, they actually help you towards the grand challenge. What are these grand challenges? Well, these grand challenges are the objectives that you're actually trying to solve this storyline. There were 12 last year. They range in difficulty, so the easiest is usually the first one. It gets a little bit difficult, more difficult as it goes on, the last one being probably the hardest, right? But you want to solve these, and then you can kind of enter into this contest if you want to have a write-up. So what kind of challenges are we looking at, right? There was a wide range of challenges, both offensive and defensive, which I thought was pretty neat, right? You think of Holiday Hack Challenge, you'd always think of hacking, right? You think of something offensive, exploitation, whatever, but it's not necessarily the case. They've actually done a variety of different things. So I thought this was pretty cool. I am on the offensive side, and learning the defensive techniques, these skills, these tools that defenders use was pretty fun to actually use for the first time or go a little bit more in depth on something that I had not done previously. There was even a full Splunk Enterprise instance available to you. So if you've never heard of Splunk before or never used Splunk before, you can actually use it here in the Holiday Hack Challenge. You can log in and run queries, run pivot searches, stuff like that. And if you haven't even done that before, they have these little side challenges that help you learn that whole process. So if you never even logged into Splunk, here's your opportunity. Literally, Splunk was a sponsor, and it was pretty neat. Okay, like I said, there's also offensive stuff, a lot of different type of offensive things, but it wasn't like run nmap, run metasploit, run this exploit. Like that wasn't what the whole offensive side was in this. I thought it was pretty neat because there were things like machine learning, a lot of scripting to automate your attacks, so to speak. I'll dive in a little bit more about the machine learning thing because I thought that was pretty cool. But just know that it wasn't just run this exploit. It was more so run this technology in a malicious way, in a way that an attacker would. And again, really cool stuff in my opinion. You will see scripts. Scripting is very common when you're doing technology stuff. A lot of times you either write your own scripts or they give you something to modify in order for it to work. Different languages that you may or may not have used before. So it just kind of opens you up to things that may be new, right? Because learning is fun, that's why we're doing this. Here's a list of the miscellaneous items that I didn't necessarily have a category for, but I wanted to actually show, right? These are things that if you actually completed the entire Holiday Hack Challenge, you would have actually done and used all of these skills here, all of these tools. Again, in my opinion, pretty cool. There was even a challenge around key bidding. I did not know what key bidding was. First time it was really introduced to me, but essentially it's a way that if someone were to take a picture of your car keys or your house keys or whatever has little cuts in it, if they took a picture of it and posted it somewhere that you can see, you can actually reverse that out and duplicate that key physically just by having the bidding data of that. So don't post your house keys online because someone can actually make a physical copy of it. And we actually demonstrated that in the Holiday Hack Challenge. Again, pretty neat stuff. Okay. So, there are a lot of write-ups already online. This challenge has been going on for a couple months now. The winners have been announced, so there are plenty of places you can go to actually read about and learn the steps needed in order to figure out each challenge. I'm not going to do that. Instead, I'm going to go more of a high level. Rather than 10,000 feet, maybe 3,000, 4,000, maybe 1,000, but not granular enough to where these steps are repeatable. Is Juris in the house? Is Juris anywhere? I want you to talk, man. Talk this way. There will be no code on here, just for you. Because, we don't want to see code, right? I mean, if you want to see code, go to my write-up. I have everything there, all the links, all the things you need for it. That's not what I'm trying to do, but hopefully this is a way that kind of gets you interested in doing the Holiday Hack Challenge, and I'm just kind of showing you my thought process, what happened. Okay, so as we progressed through the Holiday Hack Challenge, We are presented with Objective 8, so we're a little bit further down in the difficulty. Objective 8. Our job was to bypass this Frito Slay CAPTIA. I think I'm saying that right, CAPTIA. What is a CAPTIA? It's a CAPTCHA. Essentially, it's a CAPTCHA. You notice in the Holiday Hack Challenge, they like to do spin-off of words. So, know when you're home is the elf on the shelf. CAPTIA is a CAPTCHA. So, I'm just going to say CAPTCHA. Okay, so for this objective, what happens is we're navigating through this Holiday Hack Challenge, like KringleCon. We bump into this NPC. The guy's name is Krampus. And Krampus is looking for some help. The thing is, he's trying to enter into this cookie contest because if you win this cookie contest, you're given a lifetime supply of cookies. The problem is, in order to enter into this contest, you need to be an elf. They blocked it so that humans are not able to submit an entry into this. And what this defense mechanism is this CAPTCHA portal. What does that look like? Well, here's what it is. Essentially, this CAPTCHA has 100 images, ranging in items, right? Christmas trees, Christmas presents, candy canes, things like that. And we're given an option to choose 3 images that they tell us what they are, right? And select all those images that match that item. The problem is, in order to do that, we have to do it all under 5 seconds. So you don't have all the time in the world to select each one individually. You actually have to identify them within 5 seconds. So what's the problem here? Well, the problem is that that's impossible, right? There's 100 images to be able to go through to identify and to answer. We cannot do that ourselves. We need to figure out a way to actually bypass this. So how do we bypass this? Well, we can actually use machine learning. I mentioned that this is called KringleCon, right? So the whole thing is a conference. So there are security professionals that have made videos that you can watch that may or may not pertain to the challenges that we're dealing with. So if you watch a presentation that might say, hey, this is machine learning, you should check it out if you don't know what machine learning is. But this presentation here that I'm talking about is about TensorFlow. It's this tool, it's a machine learning tool. We know some TensorFlow people, nice. So it's basically a tool that if you give it information, images in our case, if you give it images, it will learn what that image is. For example, let's say you send it a bunch of apples. Well, if you send it enough apples, if you send it another picture of an apple later on, it should identify, oh, that's an apple, right? So for the Holiday Hack Challenge, we actually installed TensorFlow. We actually got to use it. Again, it's not just knowing what it is, you're actually applying it within all of this. So you have a VM that you install, and then you give it about 25,000 images that actually starts to learn what everything is. So once we have our machine learning software set up, the next thing was to identify what actually this CAPTCHA is doing, right? What kind of communication is going on? I noticed during the whole thing that the communication, basically, when you go to the CAPTCHA, it sends you back this JSON garbage, right? And JSON has this base 64 encoded stuff in there, right? So what does that really mean? I'm kind of confused because what actually happens is all 100 images are base 64 encoded. So if you were to take one image or one item from that JSON dataset, it would actually decode to a PNG image. So now, TensorFlow, if you were to give that base 64 to TensorFlow, decode it, it starts to understand what you're giving it. So how did I solve this challenge? Well, I'm not going in depth on everything. I'm just kind of giving you an idea of what it is. So maybe you want to apply this yourself. But I use Python. I won't bore you with the code again, but here's just a high level. So my steps that I took for this was the first thing was to identify the 3 items the CAPTCHA actually gave us, right? So we go to this CAPTCHA portal. It says, choose a Christmas present, a Santa hat, and a Christmas tree or whatever. We had to identify that from the response that was given to us through the CAPTCHA. The next thing was decoding the JSON base 64 syntax, right? So now we have 100 images that are in PNG format. We then send all 100 images through TensorFlow, so now it's able to identify if one of those items matches one of the 3 items given to us. After that, we needed to figure out how to respond back to it. This CAPTCHA has a response that we need to give it. Once we figured that out, we were good to go, and we were able to bypass this CAPTCHA. I thought it was pretty neat. That's why I'm trying to explain it right now. Hopefully I did a good job. All right, so the next objective number 9. This was the one right after objective number 8, right? So after we helped Krampus, submit an entry into this cookie contest, he's like, dude, thanks so much for the help. You helped me out here. You've gained my trust. I got this problem, right? The problem is I'm this owner, I'm this webmaster of this website, and I can't access it. I locked myself out. I don't know the credentials. Can you hack my website for me? So he actually gives us permission to hack his website. We are led on that SQL injection is a vulnerability that we might want to look for, so we kind of have an idea of what we're trying to actually solve here. So we're given this website. When we go to the link that's provided, right, and we notice that it's like some ELF University student portal where students are able to like log in, or not necessarily log in, but like apply for classes, check their application statuses, and stuff like that. So as we're actually navigating around this website, right, we're looking for SQL injection, right? We're calling the website looking for something that we can inject into. So we come across this application form. If we were to just submit an entry like any other person would, we would get a message saying, thank you very much, your application has been successfully received, and that's it. However, if we were to go back to that same form and actually put an apostrophe within the first name field, right? An apostrophe is kind of like a basic test when you're trying to look for a SQL injection flaw. If we were to send that, we receive this message right here, right? So this is a SQL syntax error message stating for us, or at least leading on, that maybe a vulnerability is present, right? Maybe a SQL injection vulnerability is present. How do we exploit something like this? Well, as I'm going through the exploitation process, right, I'm using something like Burp Suite. You can use whatever you want, but if I were to send that to the repeater and start manually looking for this vulnerability, I would get this message right here, basically saying that my token is invalid or expired, right? So what does that mean? What's actually happening here? Well, I noticed, right, so I'm looking through my proxy history, I'm trying to understand why I'm getting a message like this, and what's happening is there's this token that is being added to our submission form on its own, right? And if we do not have that token, then we actually get an error message saying that the token's wrong for whatever case. But if we were to include that token, like it is done automatically without us doing a manual process, then we would be okay. The problem is we're not. So at this point, we know that SQL injection is a vulnerability present. We're having trouble exploiting it because of this token, right? The CSRF token is preventing us from actually doing anything. So how was I able to bypass this? Well, anybody know what SQL map is? Hopefully someone? Okay. Well, SQL map is an automation tool used for SQL injection. So if you find SQL injection, you can use something like SQL map to automate the attack of that vulnerability. So I used that for this exercise. The problem is I kept getting that same error message, right? Saying that my token is invalid because I'm not updating my request with the proper token. So this is where a module within SQL map comes into play. It's called tamper scripts, and it's basically a way that you can become more granular with your attack or granular with your request that you're submitting. So I created a custom tamper scripts module within Python that was able to pull the token that was being grabbed before my request and including that within my actual application form request. Once I was able to do that, that message now went away. The problem is then, the way I was actually running my attack, and this was probably a fault of my own, but the request header that I was submitting was incorrect. Essentially what I did to correct the header was I used Burp Suite, their match and replace functionality. So I proxied SQL map through Burp Suite, found the incorrect header that I was submitting, and then I replaced it with the correct header, and then sent it on its way to the web server. At that point, everything was fine, my attack was able to go through, and then using SQL map, I was able to actually exploit this vulnerability. Okay, so objective 10. This was the next objective and everything, and honestly, it was probably the most fun for me. It was difficult, but it was manageable, and I'll try to break down the steps needed because that's what everything is, right? You're trying to break down these difficult tasks into something a little bit more manageable. So this challenge, we use IDA. IDA, if you don't know what that is, IDA Pro. It's a disassembler. We actually used IDA in this challenge. We used Wireshark. We had scripting. There was some reversing going on. A lot of cool stuff. So after we helped cramp this with the SQL injection vulnerability, he then says to us, right, he's like, dude, thanks for giving me access to my website. I'm finally back online. I can do stuff. But check this out. I noticed that there was this encrypted document that was on my web server. And it appeared that the attacker was trying to exfiltrate this encrypted document. He then goes on to say that this encrypted document appeared to be encrypted by this piece of software that they use at the university. And the problem is, in order to decrypt a document, you need to have the secret ID. That secret ID will give you the decryption key in order to decrypt that document. So, for this objective, we were given some information to help us with this exercise, right? We were given the encrypted document itself. We were also given the tool used to encrypt and decrypt documents, essentially. This document being one of them, if we can figure out a way how. And we were also given the time frame in which they believe this document was encrypted out. Let's just say December 7th at 7 or 9 p.m. is when they believe this document was encrypted. So we're given everything we needed in order to solve this exercise, but how do we actually do that? Well, it comes down to understanding that we have this encrypted document, we need to decrypt it, right? And this can ultimately be done with brute force. Okay, so first, before we start going down that hole, right, we got to understand and formulate ourselves a plan, right? So we want to use Wireshark because this encryption tool actually does web requests out, grabs stuff, and then brings it back in. So we can use Wireshark to capture that data. We need to do some reversing. So we need to understand what this encryption tool is actually doing. That way we can actually kind of do something with it, right? And we need to have some scripting involved in order to automate this whole process when we are brute forcing this. Okay, so our first challenge is to understand how the tool actually works, right? So what I did was I started encrypting and decrypting documents that I knew about, right? You always want to start with a base. So I created a document, let's just call it eric.txt. The contents where we're going to Eric is awesome, and we sent it through this encryption tool. What happens on the other end? Well, we were provided with the seed ID, we were provided with the secret ID, and then we were provided with the document itself that has now been decrypted. Make note of that seed ID because we will come back to that later. The next thing was the decryption process. What does that look like? Well, when we decrypt it, we actually have to provide it with the secret ID. If we provide it with the secret ID, we are then provided with the clear text document. And make note that the whole time I use Wireshark again to actually intercept this information and get an understanding of what's going on. Okay, so what is this seed ID we were given? Well, the seed ID was given to us every time we actually encrypted a document. Every time we pressed encrypt, this seed ID would be popping up to us. So what was that? Well, it turns out it was actually Unix time or epoch time. It was a string of numbers that was on our screen. If we were to decrypt that, we would be given the time frame in which we the time frame in which we encrypt our document. So when I encrypted my document, eric.txt, this seed value was given to me. Very useful later. So the next thing we need to understand was the algorithm that this tool actually used, right? This is where IDA comes into play. I'm not going to go in depth on what IDA is. That's not really in scope. But just know that when we actually disassembled our tool with IDA, we're looking around for functions, right, that might look interesting. One of the functions is actually the algorithm used by this tool. After we figured that out, we now had more information, right? What did we have? Well, we had the algorithm the tool used. That's very helpful in maybe creating a point of proof of concept, right, a POC. We also have the seed value. The seed value decrypted into the epoch time, the timestamp in which the document was encrypted, at least our document, right? And then we had the time frame in which the document was encrypted by the attacker. So we know the attacker encrypted it at a certain time, but how do we create that? Well, maybe we convert it to epoch time, right? So what did I do to solve this problem? Well, the first thing I had to do was find out what time the document was encrypted at. So we know what that is. What I did was I converted that time into epoch time and then created every single possible scenario within that time frame. That came out to be about 7,200 keys, or excuse me, 7,200 seed IDs. After that, we needed to create a script in order to figure out the decryption key. So what can be done, right? We have the algorithm in which this tool uses. We can send the seed ID, right, that epoch time, through the algorithm and actually get the decryption key. The problem is we don't know what key it is, so let's just do all 7,200 and have 7,200 possible keys. After that, the next step was pretty simple. We now had 7,200 possible decryption keys. We now created another script that would decrypt that document each and every time. It would fail 7,199 times, but one time it would actually work. That one that worked is the key that we needed, and we were able to decrypt the document to the correct PDF format. Yes?
Yeah. Did you go through 7,199 bad documents to find the right one, or did you write another script in order to find the right document?
Yeah, so the question was, did I create 7,199 documents, fake documents, in order to figure this out? No. I had about one document, but I had 7,200 keys, one of which would decrypt that document. So I had 7,199 failures.
Did you go through each one individually?
No, I created a script that would run that. Okay. Absolutely, yes. Great question. So you would have a lot of fails, so an exported document would not occur, but there was collisions. So I did have about 10 collisions where it was a valid decryption key because someone around that same time frame created an encryption, or excuse me, created an encrypted document, but it wasn't the right key for that document. So I did have some collisions where I had a document that was corrupted. However, I just kind of manually went through all 10 or 15 of those, and one of which was actually the clear text document. All right. So this will be the last exercise I'll be going through. It's the 11th one, right? I'm kind of going through order here just to kind of get an idea and make you understand what the whole theme looks like. So the 10th block, or excuse me, the whatever exercise, actually I might have missed one, right? So the 11th exercise actually is where we figure out who the villain is in this whole thing, right? So the villain of this operation that we're talking about, their name was written on the sheet of paper, and this sheet of paper was locked away in some crate. The problem is this crate was locked, so we need to figure out how to unlock this crate. So there were 10 locks that were on this crate. This crate was essentially a website, right? That's what the crate looked like. It was a website. And there were 10 locks on this website. In order to unlock each lock, there were a series of riddles to help you kind of figure out what the code would be. So one of the riddles would look something like, open the console and scroll a little. So what does that mean? Well, if we start understanding what the riddle's trying to tell us, basically it's telling us to, if we were to open up our websites, or excuse me, our web browser's developer tools, we would go to the console tab, click on that, and then we would see this code, this 8-digit alphanumeric code. And what that code would do would unlock that lock, right? So if we did that 10 times with the 10 different riddles on 10 different processes, that's what all 10 locks look like. So they all had the same process. The problem was all 10 crates or all 10 locks would refresh every time we refresh the website. So if we were to go back to the website, press the refresh button, and go through that same process for lock number 1, it would be a different code. So if the code used to be 1, 2, 3, 4, 5, we click refresh, and now it'll be 5, 4, 3, 2, 1, right? So we actually have to understand what the process was, not necessarily what the code was of that process, if that makes sense. So all of this can be done through your web browser's developer tools. So if you've never used developer tools before, this is a great exercise to kind of navigate around and understand what's going on in your browser, because a lot of stuff goes on in your browser that you don't actually see. So upon completing this exercise, unlocking all 10 locks, we are presented with an image who says who the villain is. We're also given the amount of time it took us to solve it. So in this case, it took 4 minutes and 28 seconds, and we were given a rank. Our rank is called casual, which kind of sucks, right? No one wants to be casual. We're not here to be casual. But since we had our web browser's developer tools open, right, we're able to kind of see more stuff that's going on. There was this hidden message given to us, like this side challenge. What did this side challenge say? Well, it said something like, well done, do you have what it takes to crack the crate in under 3 minutes? I thought to myself, well, I already figured out this challenge. I've already defeated this challenge, but there's this side challenge that it's kind of given me. Okay, well, 3 minutes, I can do that. So I refreshed the page. I answered all the questions to unlock the locks. Once I submitted it, a new message appeared that said, good job. Do you have what it takes to unlock the crate in under 1 minute? Okay, well, I could try, right? I have a process written out. I was able to kind of document everything because I kind of figured I was going to submit something. So I was like, all right, well, step 1, I do this. Step 2, I do this for each lock. I was like, all right, let's go ahead and stretch out a little bit. Let's click around as fast as we can through our web browser's developer tools, and I was able to submit an entry in under 1 minute. So then the message said to me, good job. Do you have what it takes to unlock it in under 5 seconds? And that's when I realized that this was no longer just a challenge around understanding developer tools. It was a challenge around, a side challenge, right? Because we don't have to do this, but it was a challenge around automation, right? Can you actually automate the process of your developer tools? So I decided, let's go ahead and do it, right? So in order to automate this process, I used Python, I used Bash. I also used this tool called Selenium. Selenium is this framework, I heard a woo in the background, essentially a way for you to kind of automate testing within your browser, usually done by developers. Really great for a lot of scenarios, right? Attacking maybe one scenario. So I was able to unlock 9 out of the 10 locks using this method, which was great, right? The problem is, what was that 10th lock? What was that one lock I was unable to do? Well, it turned out this lock was an image. It was actually a picture of the 8-digit numeric code. And my script was grabbing out text, right? I was repping through stuff and cutting through things, and I couldn't do that with what I had. In order to figure that out, I found a tool. It was called Tesseract. Tesseract is an open source text recognition engine. It essentially allows you to extract printed text from images. So I kind of started to understand what this tool was. It felt like it was going to do what I wanted it to do. So I incorporated it into my script. At that point, I was good to go. I was able to actually unlock all 10 locks with automation rather than having to go manually through each developer tool, or through the developer tools manually for each lock. Ultimately, I was able to solve the objective in about 1.5 seconds, which I was very proud of. Okay, enough about the challenge, or enough about the objectives or whatever that we went through. What were some of those challenges? Well, let's think about it. One of the most rewarding challenges, and really the only challenge I could think of, was the fact that I actually had to learn something. I actually had to figure out a problem that I didn't know already, right? I mean, we all love puzzles, I'm assuming. We all love challenges, but if we don't know something, what are we going to do? Give up? I don't know. I didn't. I actually had to learn something. For example, Splunk. I had not used Splunk before. I've heard of Splunk. It's something that I'm very familiar with as a product, but I never used it before. However, in the Holiday Hack Challenge, I was able to actually dive into Splunk, log in, run queries, pivot, learn what this actual tool actually does. There was also another tool that I found really interesting. It was called JQ. I had never used JQ before. Essentially, I had this, yeah, Trent knows. I had this tool called JQ. So basically, it's a way if you have a bunch of JSON syntax, like hundreds of thousands of lines of JSON, JQ can help you parse that. It essentially, think of it as sed, awk, and grep all at once. I mean, it's awesome. So now if I have JSON data, I'm resorting to JQ because I learned it from this holiday hack challenge. Okay, let's talk about reporting real quick. Reporting is something that we never really think about, but it's something that we know we have to do. It's something that's very common in pen testing. If you're submitting a write-up for a challenge, a CTF, a puzzle, whatever it is, we need to have some type of report on it, right? We need to explain what we did, right? The problem is a lot of times when we're going through all these challenges, we figure out a problem and then we go to the next one because we're like, hell yeah, the next one, right? And then you're on your way. But if you go back to that first one and you don't have good enough notes, you're gonna not know how you actually solved it, right? You're gonna come back and like write the report and you're like, I forgot number one, that was weeks ago. What do I actually have to do? So take good notes, right? Make sure you actually document what it took in order for you to do it. That way you can replicate your steps. But in order to, for this holiday hack challenge, you don't have to submit a report. A lot of people didn't. There's numbers around that. You don't have to. But if this is something you want to do in order to win, subscription to Net Wars or have an opportunity for SANS training, here's what I did. Not that I won, but I guess I was close. All reports are going to look different. There's people that even made YouTube videos of their explanation of each objective. I mean, it's awesome. You should probably check it out because it's way better than mine. But for mine, it was just a PDF document. I had about 180 pages total. Since I had so much content in it, so many objectives, I put it all in a table of contents. That way, if you wanted to jump to objective 7 or objective 10, you can just click there. I included as much output as I could in order for the reader to understand what they're looking at, right? So if the question said, do this, the answer was do that. I tried to document that and actually put that in my write-up. I certainly put screenshots in the write-up. That way it helps, again, the reader to understand kind of where they are. If they're lost or they're just reading a bunch of text, they can look at a picture to better understand. So for my write-up, ultimately, I did solve every objective. So we started off with those Raspberry Pi terminals. I solved all of those. I had the main objectives, the grand challenges. I solved all of those as well. And then there's also these like mini challenges. So the crate in under 5 seconds is a mini challenge, something that you don't have to do. But for me, I submitted that, and I guess I got honorable mention or whatever, so that was pretty cool. There's also one around this holiday hack trail, which is like the Oregon Trail. They had difficulties on easy, medium, and hard. I wrote about that, kind of documented what it took in order to defeat each and every one. But I mean, this is just something that I did for my report. I mean, you don't have to do it. There's plenty of people that did different things, but this was just my way to do it, and I guess I did all right. All right, so to wrap this up, I know it's getting late, guys. Thanks for sticking around. To wrap this up, this was just my experience with the Holiday Hack Challenge of 2019. I mean, I had done it in previous years, but I never really spent a lot of time on it due to a lot of different reasons, right? We're all getting busy, it's the holidays, you're not home, whatever. But this was the first time I actually just sat down and attempted it, and I'm really glad I did because I tried to explain all the things that I learned, right? Because like Corey said at the very beginning of the day, I mean, we all want to learn, right? This is why we do things like this. And I learned a lot. I mean, hopefully there's stuff on here that you don't know because this is an opportunity to learn. Wide variety of different challenges, right? Offensive, defensive, high difficulty, low difficulty. Things that we don't see every day. Has anyone done key bidding before? Maybe, maybe not, but this is your opportunity to do that. A lot of fun. So, I was lucky enough to have time to complete this, but I do want to enforce that this took a lot of time. I'm not trying to say that it took 10 hours or whatever. It took a little bit more than 10 hours. But I did not, I was lucky enough that I actually visited my parents over the holidays with my wife and kid, and they go to bed early because they're late, they're old or whatever, and I was able to work on the challenges then, and so I was able to crack open my laptop at 8 o'clock, hack away a little bit later than I should, and then figure it out in the morning. But I mean, we're all busy people. I get that. And one thing I want to say, a wise man once told me way back in the day that, I mean, if you think you're busy, just know that between the hours of 11 p.m. and 4 a.m., it's pretty quiet. So if you don't think you're having any time to do something, just know that maybe early in the morning you can do something. But to wrap it up, join the SecKC Slack. If you're not already in there, a lot of awesome people in there. I hear you all in the background. I mean, it's a great channel. CTF specifically has been very active lately. A lot of people getting into these puzzles, getting into CTFs, just trying to learn new things. And a lot of people that you can actually bounce ideas off of, regardless of what channel you're in. But at the bottom is the write-up to my right, or excuse me, is the link to my write-up. If you want to read it, it's all there. I go into a lot more depth on each and every topic. So hopefully you can check that out if you want to. But that's about it. If you want to chat later, I'll be here for a little bit, but thanks.
Oh, I turned it off. You're good. Okay.
Wow, well done, gents. Thank you, Brent, Eric. Good material, legit stuff. Thank you all for coming. Thank you for being a part this evening, and stay well. We'll see you next month.
That was awesome.
Thanks, dude.
Thank you.